Hey, what's up? My name is Alex Zablov and I have developed a new plugin for Unreal Engine 5.7. As you might know that if you have any HISM components in your level, they must share the same material and the same mesh, static mesh. Otherwise, they can't be an HISM instances of one component. And I have developed a plugin which actually resolve this problem. As you might see, at runtime I have an HISM component with many hundreds of instances, and they change their material at runtime. Frankly, it's turnaround of the limitation, and actually it's not one HISM component now, it's two HISM components, and with the help of my plugin you can instantly remove one instance and replace it with another instance for another HISM component. It has like a visual artifacts like flickering, as you might see, but it's not possible to remove because this is how HISM works. When you replace an instance, you will see this flickering anyway. I'll show you, I'll prove that later. Just be with me and let's start. I'll explain you how to use this plugin. First of all, you have to download it from Fab, and then you can find it in Plugins, Engine Tools, and here is Advanced HISM. It's a blueprint library, functional library, and here it is. It's already installed in my project. So then you can create any blueprint class for your purposes, and then you just have to create your own hierarchical instanced static mesh component as you would do regularly, and the only distinguish is that you should search now for num in the details panel, and you'll see here num custom data floats, and in my case now it's equal 1. So let me explain. Each instance can keep some data into itself. Each HISM instance, and you can store any data in HISM instance with help of this node set custom data value. It's just a standard node for Unreal Engine. They're not from my library, and here you set the custom data index. You can store data in any indexes. You can store different data, and in my case I store these data, the index of instance, and I save it for the same instance. So in my case, in other words, each instance store its index. Why do we need that? Because when you use a hierarchical instanced static mesh component, and if you dynamically remove instances, it shuffles its indices. And for example, when you remove one or two or a half of instances, they will not have the same indices as they had initially. For example, this index 1, this index 2. If you remove index 1, this is not going to be already 1. This is not going to be 2. It might be already 7. Something like that. So something strange is happening when you remove indexes in HISM components, because it's mainly designed for optimization, and it has like another structure, not as regular arrays like data arrays. It literally really shuffle or maybe switch indexes. For example, it can replace the first and the last index, etc. So that's why you can't trace indices in a regular way. That's why you should store all indices in custom data value. You can make your own research if you don't believe, but I would not do that on your place. Just believe me, I spent a lot of time to figure out how it works. And yeah, so let's come back to the gist of my library. I don't know, I'm going to distribute it for free this time, especially at the beginning. Maybe later I'll set some price, but I'm not sure about that. So now it's gonna be free, right? Today and tomorrow for sure. You can check out the link in the comment section, and so you can find it. You can find out the price. And well, let me explain. I have created one interesting node. It calls make HISM copy. It's specially to make this logic. So first of all, I have original HISM component, and with help of that node, I create absolutely the same copy with the same characteristic. And then I just set another material for it. Here is the original component with this material 1. This is the copy with material 2, red color. And then we just create a regular logic for an array, and then we add instances to our original HISM, so yellow instances. And then we store our custom data indices. In each instance we store its index, and then we add all real array indices in an array, array of variable. And the last thing, we just have to get the number of our instances, how much have we added, and then promote it to a variable. Yeah, here it is. So that's all. We have this array already. And now in the event graph, we should create a custom event, and we should call it somehow. In our case, now I'm showcasing this event. By the way, you can download this map, this level, and project. So you can take a look. You can find the link on fab.com. There is a link with this project if you need. And so now we are working on with replace with HISM custom event. And what it does is that it has a kind of loop. It gets the real array ID, and then depending on the direction, it either move instance from one HISM to another by float, from original to second, or if the direction is opposite, from this side to this side, from red to yellow, it works with this node, the same node, but other inputs. Delete from second HISM and add to original HISM. And custom data is our ID, which we got from here. Yeah, that's all. And this is the real very basic logic. You can probably understand it. You just increase and decrease the current element, and that's all. And with help of this functional library, finally we can what we can do, guys, we can change materials on HISM instances. For example, imagine if you have lamps in a building and they have lighting material. When the lamps are turned on, they have one material. When they turn off, they have another material, because it's already without light elimination, or how to say that. So we need another material for different states of lamps. That's what I mean. And with HISM, we can't have different materials for different instances in one component. And that's a real drawback of HISM. But we want to keep performance. That's why we should use this approach. You can download this library and you can use these nodes, this and this one. It's pretty, helpful and useful. It speeds up the process. And another interesting thing, that sometimes, for example, you have a lot of furniture in buildings, and they should also be HISM, because furniture is far away from you, from the camera, from the character, and you still cannot interact with it. That's why you should keep it in HISM component. And then when you come closer, probably you would like to interact with each cabinet, with each wardrobe. You want to pull out drawers, etc. And that's why you maybe would like to replace each individual instance with either StaticMesh or with child actor component. For example, if you want an interactive stuff, you should replace with child actor, like when you can interact with something. Or if you just want to turn on physics, you can use StaticMesh. Replace with StaticMesh. How I do that is the next thing which I would like to tell you about. So for that, I use node replace HISM instance with StaticMesh. And also I have a node which converts an instance back, replace component with HISM instance. So the logic is similar, you just can probably understand it by analyzing all nodes here. So for example, if the movement is forward, we just replace an HISM instance with the StaticMesh, then we set material to it, then we set simulate physics, and then we save the real ID and the StaticMesh itself to have ability to remove it later and to access and remove. And then when we go backward, we are searching for the StaticMesh by its ID, and we replace the component with HISM instance. It does under the hood removing, so it's deleting the StaticMesh, and then you also should remove this line from the map itself, because map still keeps the null pointer and the ID. You should remove it as well, and then you just increase or decrease elements. That's simple logic individually for this animation, but you can use it, for example, with cases when you come closer or far from objects. You can trace the distance between character and between HISM component. So yeah, let me enter the name of the event to this field, and now you can see that it has physics, but before it was HISM component. It means that initially it couldn't have physics, and now it can. That's really funny, and it can convert them backward as well. Yeah, I believe that's a pretty cool tool, maybe it can help somebody with your development process. Yeah, to run this logic, you should set timer by function name. You just set timer by function name, and yeah, then you just copy the name of your event, and then you set time, and then you press looping, enable looping, and here it is. And actually you can apply any logic to your event and it will invoke every second, or any other time you set up. Well, what is the next? The next thing I want to show you is replace with child actor. You probably already understand how it works, but let me show. I have a child actor cube blueprint. Here it is. It's like absolutely the same cube but with another material, and yeah, now you can see that it is replacing HISM instances with child actor components. That's very useful. Now they are supposed to be interactive. You can come closer and you can interact with them because they are real child actors and not just regular instances. And the last thing, I just wanted to prove you that it's not my bug. It's not my bug that there is flickering. It's just how HISM components work. And we have an event here, remove instance. It's just absolutely regular node from Unreal Engine. It's not made by me. It's made by Epic Games. And now I'll run it and you'll see flickering. You see flickering and some other stuff here, etc. Do you see it? You probably can see it because it flickers only on one frame randomly. When you remove something, it flickers. Yeah, it's not my bug. It's just how HISM works. You can't get rid of it, unfortunately. But if you want to have performance of HISM and functionality of real static meshes or real blueprint components, you can use this function library, download it from fab.com and enjoy game development. So see you guys. It was Alex Zablov and goodbye.